Okay, in our previous video, we talked about the tensor reshape operation over there, right? And if you remember, we started with a problem like this images stacking one by one, and we wanted to create a single image where the image 1 and 2 are side by side and image 3 and 4 are side by side over there, right? And while doing that, we talked about a reshape operation which actually transformed this single stack of image to a double stack, and over there 1 and 2 are stacked together and 3 and 4 are stacked together over there, right? Now we still not achieved the final product over here because we need to discuss about the tensor transpose operation, okay, which will help us to achieve the final product as well. So but over there I realized like I was actually not consistent on the axes over there, even though that will not basically change anything about this particular reshape operation, but I think it is always good to be consistent on the axis notation, whatever I'm talking about. If you see it over here, like we have this two means like we have 2 rows over here, correct? And this 2 means we have 2 images for each and every row over there, right? Now when we talk about a particular image, we have 3 layers over there, right, for red, green and blue, and each and every layer is 10 by 10 size. So ideally this 3, so if I just select the pen over here, so basically this particular dimension, or basically this axis dimension, we need to write before this 10 over 10 over here, okay? In that way we will be consistent, because we will be always going by the sample level, then we will be talking about the dimension of the individual layers over here, okay? So because when we'll be working in NumPy or anything like in TensorFlow, it will be in the similar way as well. So that's why I think it is always better to follow that particular notation as well, like that particular dimension sequence as well over here, okay? So in that case, if I just talk about the original image we have started with, so for this particular image, so previously we were writing something like 4 into 10 by 10 by 3. I just keep this 3 over here so that we have 4 images and each and every image has 3 layers, okay? Then each and every layer is 10 by 10 size. That is what it is, okay? Even for the final image as well, it is a 20 by 20 image and it is having 3 layers. That means 3 comma 20 comma 20, that will be its shape over here, okay? We will not say 20 over 20 over 3 over here, okay? So that means we need to basically transform this image from 4 3 10 10 to 3 20 20 over here, okay? So as we have seen the reshape operation over there, so what we did, we just basically broken down this particular axis to 2 over 2 over here, correct? So that is what, while basically talking about the reshape operation, we can see it, right? So that basically creates this 2 rows over here. Each and every row is having this image 1 and 2 and 3 and 4 over here, okay? So basically created a 5D tensor from this 4D tensor over here. So the shape of this one is 2 2 3 10 10 over here, okay? And we have seen in the reshape operation, if you just work on the adjacent axes, it does not basically destroy the image integrity over there, correct? So now with this one, let's talk about the transpose operation over here, okay, which is a very interesting one as well, okay? So we will start with the similar stuff which we talked in the reshape operation. So basically we will be creating a model of that particular image with only the first 4 pixels values for each and every layer, and we will be taking the first 2 rows over here. That means we will be basically working with 8 pixels over here, okay? So this is our red layer, this is our green layer, and this is our blue layer over here, right? So if we just talk about the scale down version of that particular image, so this is how it will be looking like, a particular image over there, right? So this is our red layer, green layer and blue layer over here. So this is a nothing but a 3D tensor over here, correct? Now we can and we have seen it in the reshape video as well. We can create this kind of image data using a numpy array over here, right? And we have given it a name called sample 3D tensor over there, right? And if we just talk about its shape, so it has 3 layers. If you see it, each and every layer is 2/4 because we have taken total 8 pixels over there, right? For each and every row there are 4 pixels over here. Okay, now if I just talk about its size, it's 24 because we just need to multiply all these dimensional values to get the size over here. Now let's move on. Now let's try to understand the transpose operation. Okay, now to understand the transpose operation, we need to understand the concept of axis over here. If you have seen, like when at the beginning of this particular video, I have worked on the sequencing of the axis sequencing over there, because this is very much important, and this is how the NumPy or TensorFlow will be operating on the tensors as well. Okay, so now in terms of axis, now this is nothing but a 3D tensor over here, correct? Now we have seen in our different types of tensor video, in the 3D tensor we have 3-dimensional, that means 3 axes we have it, right? Now if you see the axis over here, so this is the axis number 0, we will say. Okay, that means the across the different layers of that particular image over there. That means we will be going across the sample first, then we will be talking about each and every layer of the sample or anything like that. Okay, so this is our axis 0, which is nothing but our sample level, or basically in this case we have 3 layers of that image, so that means we're talking about the layered level over here. Okay, and this is the axis 1, that means for a particular layer, let's say we're talking about red pixels over here, so this is our axis 1, that means the row wise, each and every row wise, this is basically the column vectors over here. If you see it, like AE, BF, so this will all becomes the vectors of the axis 1. Similarly, for the axis 2, it is basically we are talking about the row level over here. Okay, now if you do a transpose operation on this particular image over here, okay, if you see, we just did a transpose operation, and this is how the output will be becoming over here. So let's analyze this one first. Okay, so if I just draw the same stuff, whatever array it has generated, the transpose operation, it will be something like this one. That means it has created from this 3 layers, it has created kind of 4 layers kind of stuff. Okay, and each and every layer now having 2/3 dimensions over here, right? Now let's try to analyze what's going on over here, and it is very easy actually. So if I just talk about this guy over here, so this axis 0 over here, correct? Now what are the different elements are there for axis 0? So if I just mark it over here, so we have this A, we have this I, and we have this Q over here, right? And if you see it, they actually constructed this guy over here. That means this is basically nothing but the axis 2 of this newly tensor we have created over here, right? It is still a 3D tensor, but the axis has been changed over here. Similarly, if you see it, this guy E, M, and U, this also constituted the second row over here, the axis 2 over here, correct? So that means the axis 0 values of our tensor number 1, okay, is actually became the axis 2. That's why I have given this yellow colored axis over here, so that we can at least know where the elements have moved over here. First thing, this one, okay? And now if you see it over here, what is my axis 1 data over here? Okay, now if you see it closely over here, the axis 1 vectors did not change. They are still at their same respective level over here, even though they have moved, which we'll see it. But A and E, A is the above level and E is the just below the E, that means just below the A over here. That means this particular vector does not change over here. Similarly, I, M, J, N, if you see it, they did not change. That means axis 1 is still in its place over there, right? But maybe it has moved to some other layers, but it is still in the axis 1 level. Those elements are correct. Now what is the axis 0 over here for the newly created tensor over here? Okay, so if I just see it, so this is my axis 0, and what are the elements constitute the axis 0? So if you see it over here, when we talk about this across level axis, right, that means we're talking about these elements over here, elements A, B, C and D, right, because this is across the layers over here. So this will be the vector for the axis 0 over here, correct? So that means if I just search this guy over here, this is nothing but our this guy over here, that means axis 2. So that's why I have given the same color over here. Okay, so our axis 2 became the axis 0. Axis 1 is still in our place, same place, the elements are same place, but the its axis 0 is becoming the axis 2 over here. That means we are basically reshuffling the axes over here in the transpose operation over here. So if I just see the shape of the newly created tensor over here, it is 4 2 3, and if you see the original shape, we have started with 3 3 2 4 over here, correct? So that means we just exactly reversed the shape over here. If you see it, 4 2 3, that means, and if you see in terms of axis also, the axes are also reversed over here, right? Because it is in the newly tensor, it is the axis 0 is actually the axis 2 of the newly created or the older tensor. Axis 1 is still in place, and axis 2 is actually the axis 0 of the newly created tensor, right? So in terms of axis, it is 2 1 0 over here, correct? So that means this is what a transpose operation is actually. You can reshuffle the axes over there, and if you see it, it does not actually destroy the integrity over here. That means we do not have any kind of elements, or let's say green or blue, starting middle of something, right, which we saw in the reshape operation, the bad reshape operations over there. When we do a particular bad reshape operation, the elements started creating from the middle of a particular line over here, particular row over there, right? But over here, if you see, the red points are still together, the green points are still together. We can easily access it over there as well, even though for a particular layer it is mixing it over here, but there is a particular pattern over here which we can see it from here. Okay, so that means by the transpose operation, we are not destroying the actual integrity of the image over there. Let's take, so if you see it, like we just given it normal transpose operation over here, correct? So now we could have write the same stuff, this same conversion we can do using the transpose, but we can simply write transpose 210, which we saw. We just, in the transpose, basically we need to give the axis number. So what permutation of the axis numbers you are going to use it for the transpose, that axis numbers you need to give it over here. That means we are basically telling, make this axis number 2 of this older one the first axis of this new one, then the axis 1, then the axis 0 over here. So that's why understanding of the axis is very much important when we talk about a transpose operation over here. And if you see it, like when we will actually work on the images, most of the times you won't be able to visualize whatever we are doing it over here, because for the higher dimensional tensors, it will be really tough to visualize them. Okay, so that's why you need to work on basically this numbers over here, how it will be looking like. So after we did the transpose 210, the shapes are actually getting reversed over here. We are seeing it over here, right? So that is the stuff we need to understand over here. So okay, but initially this visualization helps us to see through what's going on inside that image when we do the transpose operation. Let's take another example over here. Okay, so we still have our old image over here. Now this time we are doing a transpose of 1 2 0. That means 1 is becoming, so which one is axis 1? So that will become the axis 0 of our newly created tensor. Okay, so let's see how it looks like. So this will look like something like this one. Okay, let's analyze this one. So what are the elements we have from the axis 1 level? We have this A, right? We have this E over here. So that actually becomes the axis 0, because we have given the same guy over here. So this is becoming my axis 0 of the newly created tensor over here, right? So remember that this 1, 2 are actually the axis names, or basically axis numbers from the older one, the image we have started with, correct? So we are basically giving the reshuffling over here, like which axis needs to go first, right? So that means this A and E is becoming the axis 0. That means across the layer level, if you see it over here, correct? Similarly, B and F across the level, if you see it over here, okay? And if you do it for all the elements over here, it will be something like this one over here. And if you work for only one axis, it will be automatically handled for the other axis as well over there. And if you see it, the axis 2, which is nothing but E, F, G, H, this level, right? So that is becoming the axis 1. That means it will be becoming something like this one. See, A, B, C, D, E, F, G, H over here, correct? So this is becoming the axis 1 of the newly created tensor over here. Similarly, for the 0th axis, that means this A, I, and Q. So these are becoming over here, if you see the axis 2 over here, okay? So this is our axis 0. So this is our axis 1, and this is our axis 2 of the newly created tensor over here. And if you see it over here also, we have all the red points, green points, blue points together over here. And the shape, if you talk about, this is a 3D tensor which is having 2 layers, but each and every layer is 4 by 3, right? So that is what I have written it over here. So hopefully we got an idea about what transpose operation is. So in the transpose, we basically reshuffle the axis over there to create a new tensor over there, okay? Now if we just come back to our main problem we have started with, so we basically did a reshape operation before, and which has given us this particular 2 rows of images over here, correct? So the shape of this guy is, this is a 5D tensor because it is having 2 rows, each and every row is having 2 records, basically 2 images, and then each and every image is having 3 layers and 10 by 10 size over here, correct? Now if we just talk about in terms of axis for this guy, that reshaped one, so this is our axis 0, correct, across the row level or different row level. Then axis 1 is for a particular row level over here. Then axis 2 is our basically the red, green, and blue layer level. And then for each and every layer we have the row is the axis 4, and this is the axis 3 over here, correct? Now if we just, so shape is 2 to 3, 10, 10 over here. Now if we just mark the axes over here on these guys, okay, because when we do a transpose we basically give the axis numbers, we do not give the shapes over here, which we basically do in the reshape operation, okay? But in transpose we need to give the axis numbers over here. So the first 2 is our axis 0, correct? The second 2 is basically axis 1, that means these 2 images we are talking about. This 3 is axis 2, that means we are talking about the layer level. This 10 is our axis 3, and this 10 is axis 4, that means for each and every layer the dimension over here, correct? Now if we do a transpose of 20314, that means we are basically talking about this, moving this 3 as the first, okay, moving this 3 over here, then 0, that means keeping this 2 after this 3. That means if we just talk about its shape, it will be much more easier. So that we are moving this 3, that means which was previously in the second position to the first position of the tensor, okay? And then the 0, that means this 2, then this 3, okay, that means basically this 10, then we have 1, in 1 we previously having 2, that means this 2 over here, and then 4, this means this 10 over here. And if you see, like, there is a reason why we have done this, because after this transpose, if it is not hampering any image integrity over here, which we saw transpose operation do not do that, we basically created a structure something like this one over here, okay? And if you carefully notice over here, we need to basically reach a shape of 3, 20, 20. That is what our target shape is, right? And there is a reason why we reshuffle this one, because if you see it, we are just keeping 3, then this 210 and this 210 together, so that we can apply another reshape operation to combine this 2 and 10 to make it as a 20, and over here as well. That is our intention over here. Okay, and let's see this operation, how it is creating that image behind the scene. Okay, it will be interesting to see it over there. So we will be working on similar kind of model images, okay, which we saw before, and then try to see what's going on over there. So if we just talk about if we just take the 4 images over here, each and every image is having same 2 over 4, that means 8 pixels over here, okay, in 2 rows, each and every row is having 4 pixels over here. So this is how a typical this 4 image structure currently we are having, right? Image 1 and 2 are stacked together in a row, image 3 and 4 are stacked together in a row over here. This is how it will look like over there, right? To understand whether it's image 1 or 2, I just given a number over here, if you see it. Okay, so if I just talk about axis, so this is our axis 0, this is our axis 1, axis 2, axis 3 and axis 4, correct? And we have applied a tensor operation of 20314 over here, correct? Now if you see it, this will create a structure something like this one. Okay, now similar analysis, if you do it over there, it will be much more easier over there. If you see it, this 2, right, whatever we are having at the axis 2 level, it needs to go to basically in the newly created tensor, it needs to go to at the axis 0. That means across the rows. That means ideally it will be creating 2 rows again over there. Sorry, the axis 2 is over here, that means it will be creating the 3 rows, right? And each and every row, the first element will be A1, I1 and Q1 over there, correct? So if you see it over here, the A1, I1 and the Q1 are basically constituting the 3 different rows over here. Okay, so if we just mark it down over here, so this is our A1, I1 and Q1 over here, correct? Now if I just go back over here, so similarly the 0, that means this throughout this Q2, Q4 is constituting our 0 level axis, right? So this will become the axis 1 over here. That means across a particular row. Okay, so if we just locate the Q2 and Q4 over here, okay, we'll be understanding it over here. If you see it, this Q2 and Q4 over here, it is across particular row, but it's basically considered 2 different stack elements over here, correct? So this is how it is becoming. And one interesting pattern we can see it over here, after this particular tensor operation, basically all the red points are together over here. If you see it, it's in a single row. For image 1 and 2, it has created this guy. Image 3 and 4 also it has created this guy. That means it's also segregating 1 and 2 and 3 and 4 together as well. Okay, similarly for the green points and the blue points over here as well. Okay, so this is interesting over here. So if you just see it, I just mark these layers, this is different layers over here with red, green and blue over here, just so that we can understand correctly over here. And if we just apply this particular tensor transpose operation 20314, so basically what will be happening, for image 1 and 2, all the red points will be together. For 1 and 2 green points and 3 and 4 green points will be together. 1 and 2 blue points and 3 and 4 blue points will be together over here. And what is the shape of it? So this is our axis 0, axis 1, similar stuff, axis 2, axis 3, axis 4. And if we just talk about the shape, it is nothing but 3 to 10 to 10 over here, which is discussed before over there, right? So that's why if you see it, this small red strips are basically smaller compared to this boxes over here, because we have 3 rows, each and every row has having 2 elements over here, so it is having the 2 over 10, so basically 2 and 10 over here. So that's why, so that the pixel rows will be smaller over here and will be having 10 rows, something like this one. Okay, 10 layers over here, 10 layers of red pixels over there. So that is how it will be coming over there. Okay, so now it is just the reshape operation which we saw it earlier over there, right? So we are basically combining this 2 and 10 and this 2 and 10 over here to make it as 20 over here. We can do that because this will not alter the image integrity, because in reshape we can always work on the adjacent axes over there. We can always multiply or make it a factor to create new tensor over here. And if you see it from this 5D tensor, we are moving to a 3D tensor. That means a single image over there with 3 layers, correct? And each and every layer is 20 over 20 size, which we wanted to create over there, right? And if you see it, this 1 and 2 will be together, and 3 and 4 will be together over here, something like this one over here. Okay, so this 1 and 2 are side by side, and 3 and 4 are side by side as well. So if you just see it over here, so this over here we have a multiple layers, basically 10 layers of 1 and 2 pixels over here. So if we just flatten it out, basically multiply this 2 and 10 over here, you are basically kind of flattening this 3D structure over here, right, to a single plane structure over here, or 2D structure over here. That's why it is creating this particular image structure over there. Okay, similarly for 3 and 4 also same stuff is happening. So we basically created this new image where 1 and 2 and 3 and 4 are side by side. It is still having 3 layers because of this red, green and blue. Okay, but the concept wise, this is how it works over there. So we talked about 2 very important tensor operations, reshape and transpose, and how to use it to basically manipulate images over there, because many a times you will see you need to feed a particular image in a specific structure to a neural network. Okay, that time this kind of concepts will be useful over there. Okay, and as I said, when we talk about, basically we'll work with NumPy arrays or whatever it is, we will always try to maintain the axis sequence over there. Okay, so that it is easier to understand, and you will never miss like the image structure over there. Okay, so hopefully this video was helpful. See you in the next video. Next video we talk about some more fun stuff about tensors operations over there. Okay, see you in next video.